Okay, so by popular demand, we're going to start this week's set of videos off with a review of basically week two, or week one, we went over comparative advantage for the first time. So as you can see here, this is the same table which you had on exam number one, and I'm asking a question which is very similar to the question I asked on exam one. So I don't want to provide that answer at this point in time. I want to give you the opportunity to be able to solve that problem on your own. However, this is how you would think through similar problems, and just to give you an extra resource that you can refer back to and not necessarily rely on notes, but to rely on a video to help you better understand this topic. So you will not have a video quiz on this video, but this is just to help you better understand this material. So in this prompt, we are now asking that if the LP trades half of the cherries they produce, what is the most perch that they can possibly consume? So we're going to walk through this problem in a similar way that I set up the problem on the exam, where we're first going to start off thinking about the opportunity cost. So remember the OC, we're going to abbreviate this as of perch in the UP and the OC of cherries in the UP, as well as the opportunity cost of perch in the LP and the opportunity cost of cherries in the LP. So remember, one of the most important things for us to keep in mind when we think about opportunity cost is we want to remember the definition that opportunity cost is what we give up to get more of something else. So if we want to get 1,000 perch, then we have to give up 200 cherries. So to get 1 perch, we have to give up 0.2 cherries. So the opportunity cost of perch is 0.2 cherries. I'm just going to abbreviate that CH to save space. Now the opportunity cost of cherries is going to be how many perch we have to give up to get one more cherry. So if we want to get 200 cherries, then we need to give up 1,000 perch. We need to go from 0 to 200 cherries. We go from 4,000 to 3,000 perch. So to get 2 cherries, we need to give up 10 perch. To get 1 cherry, we need to give up 5 perch. We can perform that same calculation over here for the LP. So to get 100 perch, we have to give up 600 cherries. And so we simplify that down into its most basic form, and to get 1 perch, we give up 6 cherries. Then to get 600 cherries, we give up 100 perch. And so to get 1 cherry, we're going to give up 1/6 of a perch. Now, hopefully by now you'll recognize that both of these are inverses, and that's always going to be the case when we have a case where we have 2 goods, or a country producing only 2 goods. So now that we know what the opportunity costs of production of each good are, we can think about what the acceptable terms of trade may be. That because it only costs the UP 0.2 cherries to get 1 perch, then they are never going to pay more than 0.2 cherries to get 1 perch. So in other words, if they give up a perch, if they trade a perch with the LP, they're going to require more than 0.2 cherries in return. On the other hand, the LP is going to be unwilling to give up more than 6 cherries for 1 perch, because otherwise they could just decide to produce fewer cherries and get a perch at a cost of 6 cherries per perch. And so we then can realize that trade can only happen between the opportunity cost. And if we want to then think about what happens when the LP trades half of their cherries, we first need to realize that if both of these countries, the UP and the LP, are to engage in mutually beneficial trade, according to comparative advantage, and they're both going to rationally specialize in the production of the good in which they have the comparative advantage, in which they have the lowest opportunity cost. And so we can see that the UP has the comparative advantage in perch production, that it is relatively cheaper for them to produce perch, only 0.2 cherries, than it is for them to produce cherries, and it's cheaper for them to produce perch than it is for the LP to produce perch. So they're going to produce 4,000 perch and 0 cherries. Produce. And similarly, we can see that the LP has a comparative advantage in cherry production, that it only costs them 1/6 of a perch to make a cherry, to produce a cherry, and it costs the UP 5 perch to make a cherry. So they're going to produce this allocation. Now, if they didn't engage in trade, this wouldn't make sense because they then would not have any perch, and we think that due to the law of diminishing marginal utility, that we are variety-loving economic agents, that we want a combination of the two goods. And so trade is what allows us to rationally specialize according to comparative advantage. Now we're saying that the LP is going to consume half of their cherries, that they're going to trade half of them. So it means they're going to consume 1,200, and they're going to send the other 1,200 cherries over to the UP. So we would then want to know how many perch the UP is willing to send the LP in return for 1,200 cherries. In particular, this question is asking us what is the most perch they can possibly consume. And so we're not going to look for the midpoint of the terms of trade. We're going to see what is the maximum perch which will be willing to be paid per cherry. And so here we can see that the UP, so the terms of trade for cherries must fall between 5 perch per cherry and 1/6 of a perch per cherry. And it's obviously going to be maximized if we trade according to 5 perch per cherry. And so we're then going to multiply 5 perch per cherry by 1,200 cherries. And that's going to give us the amount of perch that, the maximum amount of perch that the UP would be willing to send over. If we were to do this math, we would then see that 5 perch per cherry multiplied by 1,200 cherries would be 6,000 perch. However, because they're only producing 4,000 perch, then they are only going to be able to send over 4,000 perch. So when both of these countries, the UP and the LP, rationally specialize according to comparative advantage and engage in trade, and the LP were to send over 1,200 cherries over to the UP, then the UP is going to be in a world where they have 0 perch and 1,200 cherries. They're going to consume that amount. And the LP is going to be in a world where they consume 1,200 cherries as previously indicated, but instead of consuming 200 perch, they're going to be able to consume 4,000 perch. So both of these countries are made better off. Both of these are consumption bundles which exist outside of the respective production possibilities frontiers. Obviously, this looks a little bit better for the LP, that the LP is able to consume a variety of perch and a variety of cherries, but that's just because the question that we're asking is what is the most perch they can possibly consume. But even when trade is this lopsided, both countries are going to benefit from trade. And so the answer to this question would be 4,000 perch. So hopefully this resolves some of the ambiguity, helps you better think through this problem, and you can reattempt the problem from exam number 1. Remember, there are no video quiz questions on this video, but if you have any other questions about this video, please feel free to email me with any questions you may have.